Section 10.5 is on the Pythagorean Theorem. In a right triangle, the longest side, which is the side opposite the right angle, it's called the hypotenuse. And we refer to the length of the hypotenuse generally with the letter c, a lowercase c. The other two sides of a right triangle, the two that form the right angle, are called the legs. And we refer to their lengths as a and b. And it actually doesn't matter which one you refer to as A or which one you refer to as B, but generally those are the legs of the right triangle. The Pythagorean theorem says that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. In other words, if you square one leg and add to that the square of the other leg, those will add up to the square of the length of the hypotenuse. Or, as you've probably heard, a squared plus b squared equals c squared. The main thing to remember is that c is always the hypotenuse. It's always the longest side of the right triangle. Let's take a look at a couple examples here. We need to find each missing length and round to the nearest hundredth. Okay, so here we have a right triangle. The sides marked 8 and 12 are the two legs. Doesn't really matter which one's A and which one's B, but I'll just label one as A and one as B so that we can plug it into our formula. The Pythagorean theorem says square the legs, add them together. That equals the square of the hypotenuse. So plugging in the numbers, 8 squared plus 12 squared equals c squared. And now just solve that equation for c. 64 plus 144 is equal to c squared. That adds up to 208 is equal to c squared. And to undo the square, we need to take the square root of both sides. So the square and the square root undo each other. So c is equal to the square root of 208. And plugging that into your calculator, that's approximately equal to 14.42. Remember the directions said round to the nearest hundredth. That's two numbers to the right of the decimal point. Here our next example, one leg is 4, the other leg is labeled B, and my hypotenuse is 21. So let's go ahead and label those. So B is what I don't know. 4 has to be my A, and 21 is going to be my C. I know that 21 has to be C because it's the hypotenuse. It's the side that's opposite the right angle. So a squared plus b squared equals c squared, or 4 squared plus b squared equals 21 squared. 16 plus b squared equals 441. And subtracting 16 from both sides, b squared equals 425. Notice this one's a little bit different. In the last problem I didn't know what c was. Here I don't know what b is. So when I get to this point right here, I just have to solve the equation for b. Taking the square root of each side, then b is equal to the square root of 425, which, plugging that into my calculator, is approximately equal to 20.62. Now the converse, or the opposite of the Pythagorean theorem, says that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So the original Pythagorean theorem assumes that the triangle is a right triangle and says a squared plus b squared equals c squared. The converse says that if c squared is equal to a squared plus b squared, then it is a right triangle. In other words, if the formula works, it is a right triangle. And remember, c has to be the longest side of the triangle. Now, Pythagorean triple is 3 natural numbers, that is, there's no decimals, fractions, square roots, negatives, or 0, that satisfy the Pythagorean theorem. So 3 numbers that work in the Pythagorean theorem. The most famous one is 3, 4, 5, because 3 squared plus 4 squared equals 5 squared. 9 plus 16 does equal 25. So 3, 4, 5 is called a Pythagorean triple because it works in the Pythagorean theorem, and 3, 4, and 5 are not decimals, fractions, square roots, or negatives. So the last couple examples here ask you to determine whether each set of measures can be the lengths of the sides of a triangle. Then determine whether they form a Pythagorean triple. So in other words, do these numbers work in the Pythagorean theorem? Okay, so it doesn't really matter which ones. The two shorter ones are A and B, but 53 is the longest. That has to be C. So is 28 squared plus 45 squared equal to 53 squared? And I'm going to put a question mark over the equal sign. 28 squared is 784. 45 squared is 2025. And 53 squared is 2,809. And adding those together, indeed those do add up to 2,809. So yes, this is a right triangle. Because it works in the Pythagorean theorem. Now, do these numbers form a Pythagorean triple? Are 28, 45, and 53 a Pythagorean triple? Yes, they are, because they work in the Pythagorean theorem. I'm going to abbreviate that. They work in the Pythagorean theorem, and they are natural numbers. Second example, 8, 31.5, and 32.5. Are these the sides of a right triangle? Well, in this case, my largest number, 32.5, has to be my C. So is 8 squared plus 31.5 squared equal to 32.5 squared? Is 64 plus 992.25 equal to 1056.25? And actually using my calculator, indeed they are equal to each other. 1056.25. So yes, this does make a right triangle. But is it a Pythagorean triple? No, it is not. No, not a Pythagorean triple, because even though it works in the Pythagorean theorem, we have decimals. Remember, you can't have any decimals, fractions, negatives, square roots in a Pythagorean triple. And our last example, 4 square root of 26 and 12. And actually, I might plug square root of 26 into my calculator just to kind of get a decimal approximation of that. Let me do that real quick here. So that's approximately 5.1. Now, I'm not going to use 5.1 when I plug it into the Pythagorean theorem. I just wanted to make sure that that was not my longest side. So my A and my B are going to be 4 and square root of 26, and my C is going to be 12. So is 4 squared plus square root of 26 squared equal to 12 squared? Is 16 plus square root of 26 squared is 26. Is that equal to 144? And I can tell just by looking at that it is not. 42 is not equal to 144. So it's not a right triangle. And it's not a Pythagorean triple. So, to sum up, the Pythagorean theorem says that if you have a right triangle, you square the legs, add them together, and that will equal the square of the length of the hypotenuse. The hypotenuse being the longest side of the triangle and the side that is opposite the right angle.